Hello students, as I told you in the last class, today we have to find out the width of the interference fringes. I hope you remember the expressions for the conditions of bright and dark fringes in interference pattern that will be used in the derivation. But before that, you recall the expression of R, the amplitude of the resultant wave, which is R is equal to under root a square plus b square plus 2ab cos phi. When the interference is constructive, cos phi is equal to 1. Then R maximum is equal to under root a square plus b square plus 2ab into 1, which is equal to under root a plus b whole square. Hence, R maximum is equal to a plus b. Thus, the maximum intensity I maximum proportional to R maximum square is equal to K times A plus B. When the interference is destructive, cos phi is equal to minus 1. Then R minimum is equal to under root A square plus B square plus 2AB into minus 1, which is equal to A minus B whole square. Hence, R minimum is equal to A minus B. And thus, minimum intensity I minimum proportional to R minimum square is equal to K times A minus B. The ratio of maximum to minimum intensities is then equal to A plus B whole square divided by A minus B whole square. When the amplitude of both waves are same, that is A is equal to B, then R maximum is equal to 2A and R minimum is equal to 0. And therefore, I maximum is equal to 4A square and I minimum is equal to 0, which means the dark band is perfectly dark and the contrast between bright and dark bands is the maximum. Now taking I1 is equal to A square and I2 is equal to B square, the resultant intensity I is equal to A square plus B square plus 2AB cos phi becomes I is equal to I1 plus I2 plus 2 root I1 into root I2. Also, when W1 and W2 are widths of the two slits A and B, from which light wave of intensities I1 and I2 originate, then W1 by W2 is equal to I1 by I2, which is also equal to A square by B square. This relation is useful for mathematical calculations. Now to find out the fringe width, first we try to understand with the help of diagram how a fringe is formed at a point on a screen when the waves from two slits reach there. Refer the given diagram. A and B are two fine slits, small distance d apart, and a screen is at a distance capital D from the slits. Illuminating the slits by strong monochromatic light of wavelength lambda, let the waves originating from A and B superimpose upon each other, resulting in interference pattern on the screen. The intensity of light at a point on the screen depends upon the path difference between the two waves arriving at that point from A and B. As the path difference between the waves reaching point C is 0, so the point C is the point of maximum intensity. Hence, there is a bright fringe called the central maximum. At point P, at a distance x from C, the path difference between the waves is BP minus AP. As BP is equal to under root BF square plus PF square, which is equal to under root capital D square plus x plus D by 2 whole square. Taking out capital D square common and outside the square root, BP becomes equal to capital D times 1 plus x plus d by 2 whole square divided by capital D square whole to the power half. By binomial expansion and retaining only first two terms, neglecting the higher terms, BP is equal to capital D times 1 plus half x plus d by 2 whole square divided by capital D square. Similarly, AP is equal to under root A is square plus PE square, which is equal to under root capital D square plus x minus d by 2 whole square, or AP is equal to capital D into 1 plus x minus d by 2 whole square by capital D square whole to the power half. Again, by binomial expansion and neglecting the higher terms, retaining only first two terms, AP is equal to capital D into 1 plus half x minus d by 2 whole square by capital D square. The path difference is then BP minus AP is equal to capital D into 1 plus x plus d by 2 whole square divided by 2 capital D square minus 1 minus x minus d by 2 whole square by 2 capital D square. Taking out 2d square outside, expression becomes equal to 1 by 2d into x plus d by 2 whole square minus x minus d by 2 whole square, which is equal to 1 by 2 capital D into 4x d by 2. Finally, the path difference is delta x is equal to x small d by capital D. Now recall the conditions. For bright fringes or for maxima, x small d by capital D is equal to n lambda, where n is equal to 0, 1, 2, 3 and so on. Therefore, x is equal to n lambda capital D by small d. Using this relation, we can find the location where the bright fringes or maxima are formed. When n is equal to 0, x0 is equal to 0, which is the location of central bright fringe at point C. When n is equal to 1, x1 is equal to lambda capital D by small d, which is the location of first bright fringe. When n is equal to 2, x2 is equal to 2 lambda capital D by small d, which is the location of second bright fringe. When n is equal to n, xn is equal to n lambda capital D by small d, which is the location of nth bright fringe. For dark fringes or for minima, x dash small d by capital D is equal to 2n minus 1 into lambda by 2, where n is equal to 1, 2, 3 and so on. Therefore, x dash is equal to 2n minus 1 into lambda by 2 into capital D by small d. Using this relation, we can find the location where the dark fringes or minima are formed. When n is equal to 1, x1 dash is equal to lambda by 2 into capital D by small d, which is the location of first dark fringe. When n is equal to 2, x2 dash is equal to 3 lambda by 2 into capital D by small d, which is the location of second dark fringe. When n is equal to n, xn dash is equal to 2n minus 1 into lambda by 2 into capital D by small d, which is the location of nth dark fringe. The width of a dark fringe is the separation between the centers of the two consecutive bright fringes. So, beta is equal to xn minus xn minus 1, which is equal to n lambda capital D by small d minus n minus 1 into lambda capital D by small d, or beta is equal to lambda capital D by small d. Again, the width of a bright fringe is the separation between the centers of the two consecutive dark fringes. So, beta dash is equal to xn dash minus xn minus 1 dash is equal to 2n minus 1 into lambda by 2 into capital D by small d minus 2 times n minus 1 minus 1 into lambda by 2 into capital D by small d, or beta dash is equal to lambda capital D by small d. We see that beta is equal to beta dash, which indicates that spacing between any two consecutive maxima or minima is the same. That is, all bright and dark fringes are of equal width. So we can say that the fringes are equidistant. Let us now talk about sustained interference. Sustained interference means fixed positions of maxima and minima on the screen, and the intensity of light also remains same throughout. As in case of sustained interference, the interference is permanent. Therefore, it is also known as permanent interference. The conditions for sustained interference are: number 1, two sources of light must be coherent. That is, they should emit continuous light waves of same frequency or same wavelength and having same phase or constant phase difference. Number 2, the waves from the two sources should have same amplitude. Number 3, sources should be monochromatic, that is of single color. Number 4, coherent sources must be very close to each other. Number 5, sources should be very narrow, preferably point source. Number 6, distance between the sources and the screen should be large. Number 7, the background should be dark. So here we complete the interference. We will meet with some other topic next time.